Today we will learn about the analog communication system, one of the fundamental technologies behind radio, television, and wireless communication. In this video, we will understand how analog signals are transmitted from a source to a destination and explore the function of each block inside the communication system step by step. Here is the basic block diagram of an analog communication system. From the information source all the way to the final destination, each block has an important role in transmitting the signal efficiently and accurately. Now, let's go through the system step by step. The first block is the source, also called the analog source. An analog source generates continuous time and continuous amplitude signals. Common examples include human voice, music, temperature, and light intensity. These real-world signals contain the original information that we want to transmit through the communication system. The second block is the input transducer. An input transducer converts a physical quantity or real-world signal into an electrical signal that can be processed by the communication system. For example, a microphone converts sound waves into electrical signals, a camera converts light into electrical signals, a temperature sensor converts temperature into voltage, and a pressure sensor converts pressure into electrical signals. The next block is the transmitter, which prepares the signal for efficient wireless transmission over long distances. First, the modulator combines the information signal with a high-frequency carrier using modulation techniques such as AM, FM, or PM. To generate this carrier signal, the RF oscillator produces a stable high-frequency signal, for example at 100 MHz. The signal is then boosted by the RF driver amplifier, which provides enough gain to drive the next stage. After that, the RF power amplifier significantly increases the signal power so it can propagate over long distances through the antenna. Finally, the matching network and filter ensure proper impedance, matching typically 50 ohms, and remove unwanted harmonics or spurious signals before transmission. The next block is the channel. The channel is the medium that carries the signal from transmitter to receiver. It can be wireless, where signals travel through air as radio, microwave, or millimeter wave, as in Wi-Fi, 4G, 5G, and Bluetooth. Or it can be wired, using copper cables or fiber optics, as in LAN, cable TV, and internet backbone systems. The next block is the receiver, which is responsible for extracting the original information from the received signal. It consists of several key stages, which we will now explain step by step. First, the RF filter selects the desired frequency band and removes unwanted out-of-band signals, ensuring that only the intended signal is processed. Next, the low-noise amplifier, LNA, boosts the weak received signal while adding minimal additional noise, which is crucial because signals are often very weak after traveling through the channel. Then, the mixer, together with the local oscillator, converts the RF signal down to an intermediate frequency, making it easier to process and improve selectivity. After that, the IF amplifier further amplifies the signal at this intermediate frequency stage to prepare it for demodulation. Finally, the demodulator retrieves the original message signal from the modulated carrier, completing the reception process. The next block is the output transducer. The output transducer is essentially the counterpart of the input transducer. It converts the electrical signal back into a physical form that humans can perceive. For example, a speaker converts the signal into sound, a display converts it into images or video, and in measurement systems, it can also drive actuators to produce physical motion or other outputs. The final block is the destination. The destination is the final receiver of the information, where the recovered message is interpreted and used. It can be a human user, a device, or a computer system that processes or applies the received information. This is a typical analog communication chain. On the transmitter side, speech is captured by a microphone, then amplified, modulated, and further boosted by an RF amplifier before being sent through the transmitting antenna as a radio signal. On the receiver side, the signal is picked up by the receiving antenna, amplified again in the RF stage, then demodulated to recover the original information, and finally processed by an audio amplifier before being played back through a loudspeaker. In the end, the original speech is reconstructed at the destination. With this example, we've now reached the end of this topic. I hope this video helped you gain a clearer understanding of analog communication systems. Thank you for watching, and see you in the next video.